I am K. Praveen Kumar Yadav, Assistant Professor in EEE Department. Today I will discuss about a important law, that is nothing but Ohm's law. Okay. Ohm's law is very important in electrical engineering and in electrical machines also. Our subject is electrical machines 1. So, in electrical machines also, this Ohm's law is placing very crucial role. So, for that we will discuss about this Ohm's law in this particular aspect. What is Ohm's law? So, Ohm's law is nothing but here the statement is that Ohm's law states that the current through a conductor between 2 points is directly proportional to the voltage across the 2 points. That means simply I can say that the current in a conductor is directly proportional to the voltage. That means I is directly proportional to V at constant temperature. That means constant temperature means, why the temperature is constant means, here we are taking the resistance is a constant parameter. So, to keep the resistance as a constant parameter, here we have to maintain the constant temperature. Why? Because the resistance is directly proportional to temperature. Okay. Let us discuss about this by using a wonderful animation. So, here we are having a animated video. So, let us explain this. This is a Ohm's law. So, for explaining this Ohm's law in a simple manner, we have to take an example of two beers. Let us take two containers. These two containers are with full of water, then these two are connected to with a pipe. These two are connected with a pipe, and I can adjust the positions of the two containers. One container is placed with some height compared to the other one. Just look like that. When I place the container like this, means the water is flowing from first this container to this one, because of due to this height difference. The water is flowing from one place to another place. That means the container which is placing at higher position, from that container the water is flowing to the down one. The water is flowing from height 1 to down 1, just showing with that arrow. Okay. And from this we can conclude that from this we can conclude that the water flow is directly proportional to the height. Okay. With this just concentrate on this. We can, from this example we can easily understand the Ohm's law. So, here just look at the height difference. The water flow is depends upon the height difference. When we can move the first container further, that means again we have to increase the height of the first container. First container means the water flow is some faster when compared to the first case. In that first case, the water flow is from height 1 to lower one. When we increase the height of the first container, when we again increase the height of the first container, means the water again flow from high to low, but the force is somewhat high. So, from this we can conclude that the force is directly proportional to the height. The force is directly proportional to the height. And next we have to concentrate on this thickness of the pipe. Thickness of the pipe. When the thickness, that means thin, here it is thin, so thickness. When we decrease the thickness, reduce the thickness of the pipe, in this condition also the water is flowing from high to low, but the speed, the force is less compared to first one. Okay. When we decrease, that means the thickness of the pipe will be reduces. Thickness of the pipe will reduces means less content of water will flow from high to low. Due to this, even the height is more, but the water flow is reduces compared to the first condition. So look at there. From this we can conclude that the force is inversely proportional to the height. The force is inverse proportional to the thickness. So from these two conditions we can finally write that the force is the F is equals to h by t, ignoring the constant. Ignoring the constant means here we are placing directly proportional, and these directly proportional can be replaced with equal. Equal means we have to place the constants. Here the constants will be ignored for our convenience. Okay. So F is equals to some constant into h by t. We have kept that constant some side, that is F is equals to h by t. So from this you can say that F is directly proportional to height of the container, and F is inverse proportional to thickness of the pipe. With this simple example, we have to apply this simple example to a simple circuit. The circuit containing a voltage source and a ammeter, voltmeter, a connecting wire, and a load resistance. So here we can explain the Ohm's law. The force is nothing but here current. Height is nothing but here the voltage potential difference, and the thickness is nothing but resistance of the wire. That means simply replacement. The previous circuit will be replaced with electrical circuit. There the parameters is nothing but similar parameters are here. The force is nothing but here the flow of current, that is water flow, here current flow. Height nothing but height difference. There is a height difference, here it is a potential difference. That means h is replaced with v, and the thickness of the pipe, that means there is pipe, here it is a wire. Where thickness of the pipe is more, water will flow, high content of water will flow. Here thickness of the pipe is less, then less content of water will flow. Here the thickness of the wire is more, then the maximum amount of current will flow. Thickness of the wire is less amount of current will flow. The thickness of the wire, thickness of the less high means resistance of the wire. That means if the resistance of the wire is more, means high amount of current will flow. Low amount of current will flow. If the resistance of wire is low, then high amount of current will flow. From this we can conclude that the current is directly proportional to voltage, and the current is inverse proportional to resistance. Here look at this, more potential difference, more amount of current will flow. Look at these dotted lines. If you are increasing the current voltage value, simple example, if the voltage is 10 volts, the current flow is 1 amp in the circuit. Let us take an example. If we are increasing the voltage from 10 to 20, obviously the current will flow from 1 amp to 2 amp. The rating of the current is increases by proportionate the voltage. If the more resistance, then less amount of current. That means even the voltage is more, but the resistance of the wire is more, means even the voltage is more, but the less amount of current will flow. That means if we are applying the 20 volts, according to the previous condition, we have to supply the load current, that is 2 amps, but the resistance of the wire is high, means the load we did not guess will not get the 2 amps current, maybe it will be less than 2 amps current. That means the current flow depends upon two parameters, that is one is potential difference and second one is resistance. So from this first condition, I is directly proportional to V, this is nothing but Ohm's law. That means the current flow depends upon the voltage, I is directly proportional to V. This directly proportionality will be replaced with a constant resistance R. That is V is equals to I into R. R must be kept constant, then only the Ohm's law will satisfy. To kept R must be constant, to kept the temperature must be constant. That means V is directly proportional to I into V is equals to I into R. This is about Ohm's law. I think you are getting more awareness about this Ohm's law. Okay, thank you.